Hello everyone. Again, Miss Lavnika, Miss Matei are talking about solving a quadratic equation. We've seen this before. What's different now?
Well, if you look at the quadratic equation that is given here as a first example, I've learned that I can solve it by graphing, but I forgot how to graph. And I've learned how to solve it by factoring, but I cannot factor that.
Of course you can.
No, I cannot.
I need two numbers. Yeah, I'm sure I can. I need two numbers. When I add them, what do I get? I get 2, right? When I multiply them, I get negative 1. 1 and 1. No, it seems like you're right. I cannot factor. That's very strange.
Well, yeah, there are some trinomials that cannot be factored. So what do we do now? Are we going to quit? Are we going to say...
That's it. We are happy. Cannot be factored. That's it.
No, Miss Matei, we will need to use a new form of solving, and that is solving by using quadratic formula.
Oh, that seems scary. Quadratic formula. What is that?
Well, quadratic formula was developed from the quadratic equation in a standard form.
Okay.
By completing the square, and quadratic formula goes as x equal minus b plus minus square root of b squared minus 4ac over 2a.
Oh, this seems scary. What are these a, b, and c? Let's see for my particular example, number 1. A equals, b equals, c equals. How much is a?
1, 2, and negative 1.
Oh, so basically you are telling me that the only thing I need to do now is I need to apply my quadratic formula?
That's correct.
Okay.
All you have to do, substitute coefficients a, b, and c in the quadratic formula and calculate your x-intercept. So square root of
b squared, that's a 2 squared minus 4 times 1 times
negative 1.
Negative 1 divided by
2 times 1
times 1. Okay, so my x will be negative 2 plus minus square root of 4 plus 4, that's an a.
That's
divided by 2. Any observations about that 8? How can I write it? I can write it as 4 times 2. Why do I like that 4?
Because 4 is a perfect square, so you can square root it.
So square root of. So x will be negative 2 plus minus 2 square root of 2 over 2.
That's correct.
So I can factor out of 2, right? So I'm left with a negative 1 plus minus square root of 2 over 2. So my two possibilities here are, first one is x equals negative 1 plus square root of 2, and the second one is negative 1 minus square root of 2. We really like the exact solutions, but nothing stops you to do the approximations of them, and you can do this at home. But what we really want, we want to see the exact forms, and those are the ones that include the square root.
What happened to 2's?
It's 2 times divided by 2, so I divided both the numerator and the denominator by 2.
Very good.
Okay.
So here are the two solutions and 2 x-intercepts for the first question. Let's look at the second one.
Okay. So you're telling me not even to try to factor, it won't work?
It will not work. This is not factorable equation, so let's state our values for coefficient a, b, and c.
Okay, so you have the function here.
Yep.
Let's make sure I attach the equation, right? We solve equations equals to 0. That's my equation.
That's correct.
So a, b, and c, you help me?
A is negative 3, B is 1, and C is positive 7. If we remember formula correctly, so it will be negative b,
Negative b,
which is plus minus square root of b b squared
Mm-hmm.
minus 4ac
Mm-hmm.
divide by 2 times 8.
Okay. So let's see what happens. Anything interesting happens here?
Not really. We all have to do a whole bunch of calculations.
1 plus 12 here. No, I'm
12
wrong.
times 7.
12 times 7, that is
84.
84. No perfect squares there. You pick
Nope.
them to make my life difficult, right?
So now we have square root of 85.
Which is not, is it interesting?
No, not really.
So
We
it
can
stays like that?
factor it into 2 factors. One of them would be perfect squares. So our solution is, let's change square root of 85 into a decimal, which is 9.23.
Okay. So you want me to change this into -1 plus minus 9.23.
22
22.
divide by -6.
Oh,
And now you can state 2 solutions.
x equals approximation.
Yeah.
X equals
And
approximation.
that is to be done
at home.
Okay. And we are done for solving quadratics.
There you go. And we